You type in a web address, you hit enter, and poof, a page just appears. It feels like magic, right? But behind that magic, there's this secret conversation going on. So once your browser actually finds a website, how do they talk to each other? What are the rules? And maybe most importantly, is that conversation secure?
So when your browser and a server decide to talk, they've basically got two choices. One is like, well, it's like sending a postcard, totally open for anyone to read. The other? That's like using a sealed, armored envelope. And as we're about to see, that little difference, it means everything when it comes to your safety online. All right, so to really get the secure way, we've got to start with the original language of the web, the one that kicked this whole thing off, HTTP. Okay, so HTTP, it stands for HyperText Transfer Protocol. Now, if you break that down, it's really just a fancy way of saying the rules for moving web stuff around. Think of it like this. It's the basic grammar that lets a customer, that's your browser, ask for something from a vendor, the website server.
Yeah, it's simple and it's fast. But that simplicity, it comes with a huge, and I mean huge, built-in problem. It makes the whole conversation fundamentally insecure.
The best way to really picture an HTTP conversation is to imagine the whole thing is done with postcards. Seriously, your browser writes down its request, like, hey, can I see the homepage? On a postcard, and drops it in the mail. Then the server just draws the homepage content on another postcard and sends it right back.
And right there, that's the giant security hole. I mean, imagine writing your username and password on that postcard. Anybody who touches it, the mail carrier, the person sorting the mail, anyone can just read it. That's the deal with HTTP. Any sensitive info you send is just out there, completely exposed.
So this massive security flaw was, let's be honest, a total disaster waiting to happen. It was so bad it led to a critical, much-needed upgrade. And that's when the hero of our story shows up, HTTPS. And the biggest difference is right there in the name. That S in HTTPS, it stands for secure, and it changes the entire game. We're switching from that wide-open postcard to a sealed armored envelope. No peeking allowed.
So, what's making this armored envelope? What's the secret sauce? Well, it's a technology called TLS, which stands for Transport Layer Security. This is the cryptographic protocol that's doing all the heavy lifting, creating that private, secure channel for your conversation to happen in. Okay, so how does TLS actually pull this off? How does it seal that envelope so tight? It all happens in like a fraction of a second, through this quick three-step process we can think of as a digital handshake.
Yeah, it's kind of like a secret agent meetup. First, the server has to prove it's not some imposter, so it shows its official ID, that's the TLS certificate. Next, you've got this trusted bouncer who checks the ID to make sure it's real. And then, once everyone's verified, the browser and server cook up a secret code that only the two of them will use for the rest of their chat. Pretty clever, right?
And this bouncer we're talking about? It has a proper name, a certificate authority, or a CA. These are basically trusted global organizations, and their whole job is just to confirm that a website is who it says it is. This is what stops you from accidentally spilling your secrets to a fake, malicious site.
So, this whole digital handshake thing gives you three absolutely crucial guarantees. First, encryption, so nobody can listen in. Second, integrity, which means the messages can't be messed with along the way. And third, authentication. You know for sure you're talking to the real website, not a fake one.
Okay, so your browser has sent its request, and it's all tucked away in a secure, armored envelope. The connection is safe. Great. But how does the server quickly tell your browser what happened? Did it work? Was there a problem?
It uses this system of quick, three-digit replies. We call them status codes. Just think of them as super fast shorthand for, here's what happened with your request. It's actually the very first thing the server sends back, even before the web page itself.
And these codes are all neatly organized. Anything starting with a 2, like in the 200s, means success, we're good to go. 300s mean, hang on, you're being sent somewhere else. The 400s, that's a client error, which means the mistake was probably on your end. And the 500s, that's a server error. That's the server basically saying, oops, it's not you, it's me.
Now here is a code I guarantee you've seen before.
It might just be the most famous error on the entire internet, the 404. When you see a 404 not found error, it's really just the server saying, hey, I understood what you were asking for, but I looked everywhere and I just can't find it. It usually means the link is broken, or maybe the page was moved and nobody left a forwarding address.
All right, now on the complete other end of the spectrum, we've got this beautiful number. This is the status code you always want to see. This is the goal, right here.
The 200 OK is basically the server giving you a big, cheerful thumbs up. It just means everything worked perfectly. Got your request, understood it, and here's the web page you wanted. Mission accomplished.
So, let's wrap this up. What are the big takeaways here? 1. HTTP is that insecure postcard, totally open. 2. HTTPS is the sealed, armored envelope. 3. That S for secure is all thanks to the TLS handshake. And 4. The easiest thing for you to do? Always look for that little lock icon in your browser's address bar. It's the simplest sign that your conversation is private.
So now you know the vital difference between sending a digital postcard and an armored envelope. And that leaves us with one last question to chew on. What other digital postcards might you be sending every single day without even realizing it? Thanks for watching.